Many of us grew up believing that Earth simply orbits the Sun, a blazing sphere standing still in the emptiness of space. Yet in reality, the cosmic picture is far more intricate and wondrous. As you dive deeper into the true movement of Earth through the galaxy, you'll discover our blue planet not only circles the Sun, but hurtles through space at breathtaking speed, taking our entire solar system on a grand voyage through the starry ocean. But what if we told you that this very motion could be linked to some of the universe's greatest mysteries? Scientific hypotheses suggest that as Earth swims through the Milky Way, our planet is bathed in cosmic rays, invisible arrows that can cause genetic mutations and contribute to mass extinctions of life. Even shifts in our planet's orbit around the Sun may trigger dramatic environmental changes, unleashing catastrophes such as another ice age. Only by understanding our planet's journey through the vast universe can we truly appreciate our place in the endless expanse. Perhaps, along this voyage, we'll uncover clues that could help answer some of the biggest questions. How did our galaxy come to be? And what is the meaning of our place within this grand cosmic design? And what might the future hold for us? For a moment, imagine you're inside an airplane flying at a steady speed and altitude. While seated within the cabin, you can hardly sense how fast you're traveling, or even whether you're moving at all. From your perspective, it seems as if only the world outside is shifting and drifting by. Yet, for someone watching from the ground, the plane is clearly racing across the sky, its motion obvious relative to their stationary position. This illustration, first described by Galileo Galilei in his 1632 work, Dialogue Concerning the Two Chief World Systems, gave birth to what we now call Galilean relativity, or Galilean invariance. It's the concept that asserts there is no absolute frame of reference for motion, and even when several valid frames of reference exist, we must choose the one that's most relevant to the situation. So how does all this tie into the movement of Earth and the solar system? First, we have to determine our observation point. When viewed from within our star system, as we all know, the planets orbit around the Sun. However, when we broaden our perspective, we begin to see a completely different picture. The solar system is not standing still, but constantly spiraling its way through the vastness of our galaxy. One of the most striking examples of relative motion within our solar system is Earth's revolution around the Sun. What's fascinating is that Earth's path is not a perfect circle, but rather an ellipse, with the Sun sitting at one of its foci. This means that at certain points in its orbit, Earth draws closer to the Sun, while at others, it drifts farther away. When our planet is at its closest, we call this point perihelion. When it's at its most distant, it's known as aphelion. These two positions occur at regular intervals. Earth reaches perihelion around January 3rd, and aphelion around July 4th. Intervals that become evident in the shifting seasons you experience each year. You're probably familiar with those classic depictions of the solar system, with the Sun at the center and planets orbiting in neat circles. But that's not a truly accurate representation of what's happening in our planetary neighborhood. In reality, the planets do more than simply orbit the Sun. They actually tug at the Sun itself, pulling it along as part of a ceaseless dance through the cosmos. The powerful gravitational pull of gas giants like Jupiter and Saturn causes remarkable effects on both the Sun and Earth, subtly altering the shape and orientation of their orbits. Whenever these giants even remotely align, they exert a profound influence on all the bodies within the solar system. This phenomenon is known as the perturbation of the outer planets, a silent dance strong enough to redraw the cosmic pathways of worlds over millions of years. These gentle nudges, accumulated over time, can result in sweeping changes to our planet's climate and environment. Such shifts are called Milankovitch cycles, the endless rhythm of Earth's movement, guided by the invisible hands of the cosmos. One of the most fascinating aspects of these cycles is the shifting tilt of Earth's axis, moving between about 22 and 24.5 degrees in a cycle lasting some 41,000 years. This slow but relentless change determines how much sunlight pours onto each region of Earth's surface, and, in turn, shapes the timing and severity of the great glaciation periods, the ice ages. Based on these cycles, some scientists predict that in the not-so-distant future, a new ice age may begin on our blue planet. These climate cycles can span tens of thousands of years. Yet, it's crucial to remember that anthropogenic climate change is currently suppressing Earth's natural rhythms, making it ever more difficult to predict the exact timing and severity of future ice ages. Let's face it, Earth's movement within the solar system is already staggeringly complex. But its passage through the galaxy is an even greater enigma, vast and mind-bending in its intricacy. The Milky Way, our immense and mysterious home, is a swirling collection of countless stars, clouds of gas, and cosmic dust, stretching over 100,000 light-years from end to end. One of the most enchanting wonders of our galaxy is its rotation. Like a colossal windmill, the spiral arms silently unfurl as the entire system spins. This grand rotation sets the stars, gas, and dust in circular orbits around the galactic center, a cosmic choreography that never ceases. Our Earth is nestled within one of those spiral arms, some 25,000 light-years from the galactic core. Within our solar system, there are only a handful of gravitational heavyweights to consider, with the Sun reigning as the dominant celestial body at the heart of it all. To determine the Sun's speed relative to the heart of the galaxy, scientists look for new, young stars, cosmic newborns still anchored to their birth orbits. By averaging how these youthful stars move compared to us, astronomers deduce that the Sun is drifting forward at about 3.1 miles per second, inching inward toward the galactic center at roughly 5 miles per second, and gliding up and away from the galactic disk at 4.4 miles per second. These small, seemingly subtle motions have a profound impact on the grand trajectory that the Sun and the entire solar system carve through the Milky Way. The Sun's path around the galactic center is not perfectly circular, either. It's a slightly elliptical route, oscillating up and down across the galactic plane, a gentle cosmic waltz that takes eons to complete. Once every 60 million years, the Sun completes a full oscillation above and below the galactic plane. Its journey shaped by the gravitational pull of other stars, sprawling gas clouds, and the enigmatic dark matter that haunts the universe. Right now, Earth and the Sun ride several dozen light-years above the galaxy's central plane. If you too feel both small and wondrous in the vastness of the universe, hit the like button, share your thoughts in the comments below, and spread the spirit of cosmic discovery by sharing this video. Don't forget to subscribe so you can journey with us through the mysteries of space and keep exploring humanity's extraordinary place among the stars. We are currently positioned above the galactic disk, though pinpointing the exact center is no easy feat. After all, there's more mass beneath us than above. The gravity of the disk acts as a cosmic brake, gradually slowing our upward climb. And in just a few million years, the Sun and Earth will find themselves nearly 300 light-years above the disk's center before that ascent halts, signaling the beginning of a slow descent. This vertical oscillation is more than just a cosmic oddity. Some astronomers support the Sheba hypothesis, believing that this movement could be directly linked to mass extinctions on Earth. The center of the disk is a perilous zone for our solar system, teeming with higher densities of stars and the relentless radiation they unleash. The motion of the Milky Way's spiral arms is still shrouded in mystery, but scientists theorize that it's driven by a combination of forces. One such force is the gravitational pull from other galaxies in our local group, the galactic cluster to which the Milky Way belongs. Another is the presence of density waves, believed to ripple through the galactic disk like waves across a pond, compelling stars and clouds of gas. As Earth and the solar system weave through the spiral arms of the Milky Way, the very environment and living conditions on our planet may shift dramatically. Passing through regions of higher density means Earth could be bathed in a greater shower of cosmic rays and high-energy particles, impacting our climate, atmospheric chemistry, and perhaps even the course of evolution itself. As we've discussed, the Sun is anything but stationary. It carries Earth and the other planets with it as it journeys through the galaxy's starry sea. Yet the Sun is far from alone in this grand motion. Every star in the galaxy is on its own endless migration, tracing unique paths across the cosmic canvas. The movement of these stars is defined by what astronomers call proper motion, the visible drift of stars across the night sky over time. Proper motion results from the relative movement of stars and the Sun as they travel through space. It's typically measured in arcseconds per year, the angular shift a star makes in the sky over the course of a year. This concept of proper motion enables astronomers to track the footprints of stars through the ages, unraveling the cosmic map of motion and the migratory history of the universe's celestial travelers. Determining the position of stars relative to one another is vital, as it grants us deeper insight into the structure and dynamic heartbeats of the Milky Way. Now, let's turn our gaze to Earth's motion relative to the nearest stars. As Earth orbits the Sun, the apparent positions of nearby stars in the night sky subtly shift over time, a phenomenon known as parallax. Parallax occurs because, at different times of the year, Earth occupies different places along its orbit, providing us with slightly altered viewpoints on the closest stars. The magnitude of parallax for any given star depends on its distance from Earth. The closer a star, the more pronounced its parallax. The farther away, the less noticeable the shift. Astronomers use the measured parallax to determine the distance to nearby stars, an invaluable tool in unraveling the true size and architecture of our galaxy. Beyond parallax, our perception of the night sky is also shaped by the proper motion of nearby stars. Over the course of years or decades, the apparent positions of these stellar neighbors can visibly change. The proper motion of stars means that the constellation patterns we know so well today will subtly shift over time. The star maps of the past would have looked different, and so too will those of the future. This effect is especially striking for nearby stars with large proper motion, the true speedsters on the galactic stage. Now that we've painted a breathtaking portrait of the way our solar system actually journeys through the galaxy, one grand question remains. How do we move through the universe itself? As it turns out, the Milky Way is far from alone in its cosmic travels. Our galaxy is relentlessly tugged by the gravitational fields of enormous masses all around. At this very moment, we're racing toward the Andromeda galaxy at several hundred miles per second. Yet even that's just part of the story. The Milky Way is one of more than 54 galaxies in the so-called local group, which includes our closest neighbor Andromeda. This local group, along with countless other groups and galaxy clusters, is being drawn toward a mysterious, super-dense region. A supercluster of galaxies called the Great Attractor, a region some 150 million light-years away, wields such enormous gravity that it tugs at galaxies across hundreds of millions of light-years. As a result, our local group is being pulled toward the Great Attractor at a breathtaking speed of about 373 miles per second. Yet even this is not the final word on Earth's movement in the universe. Our entire universe is expanding. All galaxies are drifting farther apart. Fascinatingly, this isn't movement through space as we know it, but a stretching of space itself, the very fabric of the cosmos expanding over time. The universe's expansion is accelerating, sending galaxies ever more distant from each other as the ages pass. Amidst all this motion, we can still use the cosmic microwave background radiation, the leftover heat from the Big Bang, as a cosmic reference point for measuring our speed against the rest of the universe. This radiation, the echo of our universe's fiery birth, permeates every corner of space and remains astonishingly uniform in all directions. By measuring the tiniest variations in this radiation, scientists have determined that Earth and our entire solar system are racing through the universe at about 229 miles per second, relative to the cosmic microwave background. By now, it's no longer a shocking revelation to anyone that Earth is anything but stationary. Rather, it is a small, yet essential player in the complex choreography of celestial motion. The impressive intricacy of our planet's movement is a breathtaking phenomenon. First, Earth gracefully circles the radiant sun, as it has done for billions of years. But that's only the tip of the cosmic iceberg. The entire solar system, with Earth as a passenger, also hurtles through the Milky Way's vast reaches, leaving behind a beautiful corkscrew trail. And still, that's not the end of it. The Milky Way itself belongs to the local group of neighboring galaxies, and together they perform their own cosmic dance as they are drawn toward the mysterious gravitational force called the Great Attractor. This cosmic tug-of-war sends our local group racing through the void at several hundred miles per second. And even that's not the end, for the universe itself is expanding, a revelation first brought to light by Edwin Hubble in the 1920s. This expansion means the galaxies are all rushing away from each other at an astonishing pace. In the end, Earth is not just a lonely rock drifting through space. It is part of a grand design, a web of cosmic motions, both intricate and awe-inspiring. We are but a speck of dust in the immensity of this universe. Yet the movement of our planet is an essential piece of the enigmatic puzzle we call space. If you too feel both small and wondrous in the vastness of the universe, hit the like button, share your thoughts in the comments below, and spread the spirit of cosmic discovery by sharing this video. Don't forget to subscribe so you can journey with us through the mysteries of space and keep exploring humanity's extraordinary place among the stars.